So, hi, welcome to next lecture. So today, so in last class we have seen the numerical, like how to do normally, okay, using the factor-based method. Fermat factorization using factor-based method. In that factor-based method, like here, because since I have given, means in the question only it's given, we are successfully happily taken this 67, 68, 69 as a B numbers and check it. But in reality, I mean in actual case, how to do it? Actually they will not give, we have to choose ourselves only. So that is the most trickiest part. So further there are some ways, okay. So first method, it's saying that fix B, okay. So take some numbers. So fix B is nothing but a list of prime numbers. Fix some B, okay. And after that choose random bi that they are B numbers, okay. They're saying that choose a random bi such that they are the B numbers. So after fixing capital B, okay, now just find the value of root n, okay. Then take nearby numbers, okay. You understand my point? Nearby numbers means, let's say root n, let's say suppose some integer 128 point something, take 128 and just try the all nearby numbers, okay, like 128, 129, 130, 131, 132, means whether these are B numbers or not with respect to this factor base. If they are B numbers, take few one and again proceed the normal procedure. So after you selecting the ones their B numbers are present, then you know what the procedure means. Out of these B numbers, we will pick BI number such that the epsilon vector will become 0. That means when you add those which are pick up elements, if you do their exponents, sigma alpha j should be even, so that by 2, sigma alpha j by 2 is nothing but epsilon vector, that is epsilon not by 2, epsilon vector is equals to alpha vector modulo 2. So it will become even mod 2 becomes 0. Okay, this we have seen, no and again repeat. Okay, this is the one procedure. Fix B factor base B and then choose the random BI numbers. Or second method says that you can choose some BI numbers on your own. I mean BI numbers such that those numbers should be means layer of that layer of B1 square mod n, that is very far less than n by 2. You understand my point? So basically this just listen one time only, don't take much. I will, when we solve the problem, you will get more clarity. Just for few, just listen like this, okay. So first take, that means a layer of bi square is far less than n by 2, where n is like it's given, okay, input only, like that, okay. N is nothing but the number which we want to factorize, okay. That's the whole basic funda. So after taking B numbers, I mean not B numbers, take a some number such that a layer of that number whole square is far less than n by 2. So let's take, you have taken B1, B2, B3 as some numbers, not a B number, okay, such that this has satisfied. Now what will you do? Now factorize this B1, B2, B3. So you will get some factors, na? I mean Jai Sri Krishna. So those factors you make as a union. So basically from the numbers form the set B. B means factor base, means previous case is that we fix on that we will fix on this what is this factor base and then proceed for B numbers. But here we will do the reverse case. Take some numbers, from that numbers factorize it and take those factors as a factor base, and say that after saying, and from this we can say that these are like b numbers with respect to this factor base, and then procedure as usual procedure. Okay, see here now I will talk about important, means when will fermat factorization using factor base fails. Okay, answer is, so if you do like this procedure, you will pakka will get that b square is congruent to c square mod n. This is for sure not a problem. The main thing like here lies, take exact value. What is exact value of b comma c? If b exactly equals to c, then we failed, means we didn't achieve output. So we have to start again this whole method from the step 1 onwards. We failed, we have to start, we failed in our process, in our goal. Okay, the goal is to find the factorization of a number. We have to start from the beginning, bro. Okay, I mean by beginning, by changing, by taking some other b numbers. Okay, by taking some other b numbers, and means b1 b2 b3 something like that, and then follow again the procedure. That is the failure case. This is what. Another case is b not equals to c. So whenever b not equals to c, what will happen, tell me? Then we succeeded, means we succeeded in our goal. Okay, so after this what is the answer, means b plus c into b minus c. Those are the factors. You got my point? This is what I said no in last class. After finding b and c, b as some how much factors will be, this will addition, subtraction. Okay, like that it will happen. Okay, you got my point. This is the one important to discuss. Now next method is continued fraction. So continued fraction method, actually see, now whatever I am discussing continued fraction method, this is the method. Actually see, in this whole thing, what is the big problem, tell me? The big problem is that actually we have to fix the numbers. I mean, what I mean to say is that, see, in the first case, so fix the b numbers in such a way, and from that we have chosen b numbers, and then we have proceed normally. Here the main tricky thing is that how will you fix this one? That is the main thing. After fixing that one, how will you find the chosen random bi number, chosen b numbers, I mean random b numbers? That is the main tricky thing now. Okay, you got my point. So now instead of this, let's say now the question is, can we have any algorithm so that this finding the b numbers, the main whole intention is to find bi. Okay, finding the b number should be a deterministic, means deterministic algorithm means there is some nice way of approach. Okay, here we are selecting by like a random, and if you have got lucky, it's happy, otherwise you have to struggle a bit. But the question is there any, can we have any deterministic algorithm to find the bi number? So the answer is yes, continued fraction method. In that continued fraction method, first discuss some concepts, some mathematical concepts, and then we will proceed. Okay, in this, what does it saying that in this continued fraction, so every number, I mean every real number means, you know, like this 24.3456780 and so on. Every real number can be expressed as a fraction. Okay, that's what it's saying. I mean, so means this can be represented as 3, 4, 5, 8 and so on. 24 plus 0.34258. Again this can be represented as 24 plus 1 by something, some fraction, like again some, and so on. Like this can be, we can write like this. Okay, this real number can be written as a like in this fashion. So this is the basic normal mathematical concept. Okay, so what I mean to say is, let's x be a real number, then it can be expressed in this form, where ai's are real, I mean integers. a1 plus a2 plus a3 plus a4 plus and so on, and means a1 plus this whole value. You got my point. Again a2 plus the whole value, again a3 plus this whole value, again a4 plus this one, like this. Okay, you got my, so like this is the basic concept. Okay, now see, now let me define some variables. Okay, let me define some variables. So I am defining variables like this. X is, I am treating x as a naught plus x naught. Okay, x equals to a naught plus x naught, and what will be the value of x naught, tell me? All a's are integers, so from this case you can derive, means just think like common sense. X minus a naught equals to x naught. Basically see bro, a naught is nothing but a fraction part of x, and x naught is nothing but I mean sorry, integer part of x. Here this is nothing but fraction part of x. Okay, this you can be thought like a x naught equals to something, okay, fraction part of x. This one you have to remember. Okay, and next one, x1, how I am defining x1 is as like this. x1 can be thought of, now see, x naught is a fraction part you know, like 0 to 1. So what will be the, take a reciprocal of this, so what will be happen, 1 by 0 will become positive infinity plus 1 by f plus 1. I mean, so 1 by f is basically greater than 1. I mean, so 1 by x naught is greater than 1. So since it is greater than 1, so 1 by x naught can be expressed as, again see, normal common sense formula. What is that common sense formula? For any real number, it can be expressed as integer plus fraction part of x. This is what we have learned in mathematics, normal 11th and 12th class now. Similarly here, according to this, what will happen, 1 by x naught plus the fraction part. Okay, this fraction part we are calling it as a, what we are calling, x1. That is how we defining the variables we are defining. Okay, x1. Okay, this fraction part is called as f1, and this number is called, this is an integer, no? This is called as a1. Okay, basically 1 by x naught equals to a1 plus x1, and again since this is a what, now take this number, so 1 by x1, again 1 by x1 is greater than 1, so a2 plus x2, again take 1 by x2 equals to a3 plus x3 and so on. Okay, from this we can conclude one formula, right? What we can conclude, ai plus 1 equals to 1 by xi for all I greater than or equals to zero. Okay, that means by using this formula we can get the values of what is a1, a2, a3 and so on. And what is a0 basically, tell me? A0 is 1.1, you can think like 1. and where a naught is equals to, I told beginning one, this is not step x. Step x means you can think like floor of x. Okay, this is the one point you have to remember. And after this, if you observe similar pattern, you can write like this formula, right? 1 by here 0, here 1 1. So 1 by xi equals to ai plus 1 plus xi plus 1, where I is greater than or equals to 0. So this is one another formula. And so this formula, it can be written as like this, reciprocal 1 by ai plus xi plus 1 for I greater than or equals to 0. So this is what all the normal mathematics concepts, okay, how we are defining the variables and etc. Okay. Now again let me define some more variables. Okay, let me define the some more variables bi comma ci. Okay, so how we are defining bi and ci means, see the word defining means that somebody given that one, so you have to follow that one. So from that we will now start of logical thinking, means from this step, if you assume like this is what the notation means, then from this notation what can the conclusions we can derive, like that we have to think. Okay, so now I am defining that b naught by c naught can be written as a naught by 1. Okay, and b1 by c1 can be written as a naught plus 1 by a1 plus 0. Okay, so you got my point, what I mean to say. That means if I said b2 by c2, then according to common sense tell me that it will become a naught plus 1 by a1 plus 1 by a2, generally 1 by a2 plus x2. It is how it will look like. Again x2 will become, what will happen, 1 by a3 plus x3. Again x3 will become how, what will happen, x3 value. So basically x2 equals to a3 plus 1 by what, tell me, x3 what is that? a4 plus x4. Again like this it will go on, and finally this is what it look like. I mean this way. So basically from this one we are deriving like this, means we are naming this thing as a x0. Similarly we are keeping this as a x1. So from this small observation we have derived these formulas. Okay, this is the basic thing, you have to derive it whenever if they ask in the exam, means not directly, but it will be helpful in the solving one problem like 6 marks 5 marks question. Okay, that's it. So that's it, you understand how to write b2 and c2. So just make it go for till this ith number, means b2 c2 means go for a2 plus instead of x2 make it as 0. So this is okay. Now this fraction is what we are calling as b2 by c2. So this can be whole, it can be written as how, a naught a1 a2, means if you solve this one, I will solve slowly, plus 1 by a2, that means a naught plus a2 by 1 plus a naught a1, I mean a1 a2. So that is a naught a1 a2 plus a1 plus a naught plus a2 by 1 plus a1 a2. Okay, samjha? So from this one, like this, by this observation they have written the formula like this, bi by ci equals to ai into bi minus 1 bi minus 2. This is the formula they have given. Okay, this you need to remember, samjha, you need to remember. Okay. So basically what is x, I told you before here only, generally normally. So here this is the whole concept, bro. Okay, now how will you apply? Now we will take this help of this concept and find the b numbers. Okay, So this whole thing now we are calling as a fermat factorization using the continued fraction approach. What? Continued fraction approach. So for that one I am telling one algorithm. So here the algorithm says it will go like this. So basically input of this algorithm is n only, output is like factors. Algo is that b minus 1, let define b minus 1 as 1, and so from this bro, see the definition is like this. From this one actually, see, whenever let's say x by y equals to 3 by 2, so what is the value of x and what is the value of y means you generally told like this. No, if anyone asks, normally we will tell like x is equal to 3 bro, y equals to 2, like this, equal. But actually in reality you tell me that x is the 3k where k belongs to z, and y equals to 2k where 2 belongs to, means if you keep on varying the z value, it will become x and y values will be changes. Means you can think x and y can be pair 3, 2 or 6, 4 or anything, any multiple of this thing. Okay, but here we are defining like this: bi equals to exactly equals to ai minus bi minus 1 plus bi minus 2. Okay, this is how we are defining. You have to remember ci is equal to ai minus ci minus 1 ci minus 2. Okay, chalo. So here b naught equals to, okay, so we are defining, array man, okay, and b naught value equals to how much? A naught, that is equals to root n. Okay, and second step, what is second step? Compute b naught square mod n. Okay, and from this, okay, basically see bro, means whenever you see SAR notes also, or what does it mean? Means you have to find LAR of b naught square mod n. Samjha? Every time I don't write LAR, whenever I write b naught square mod n, from this one you have to assume that okay, LAR is by default there, I am not writing it. This is what you have to keep in mind. Okay, this what like initially our means this was like our way of notation, no? So here whenever you see bi square is like this, but actually this is not like this. What is this? I told no, right? LAR of bi square mod n is equals to this whole value. You got my point? Like this how it works. Okay, chalo. So next step, next is take for loop I equals to 1 2, means you have to keep on iterating till you have to keep on iterating till how many b numbers you want to take. Okay, how many, according to your wish you can take as many b numbers as possible. Means see bro, okay, we will discuss about later. Let's go for algorithm. So first step will be a equals to 1 by xi minus 1 and xi equals to 1 by xi minus 1 minus ai. Okay, this is normal thing. This is what how we define. I make it as a box. 1 by xi, you keep take it left side, you will get like this. Okay, common sense. So after this, second step will be, means we have to compute, okay, values we have to compute, and after it will be bi equals to ai into bi minus 1 plus bi minus 2. Okay, this is the one. So here see, it will be like, actually truly speaking, it will be like this: LAR of this whole value mod n. Okay, means see LAR is nothing but normal mod n only. but it keeping that if suppose if you normally apply mod n, if the value will become greater than n by 2, then we will subtract to minus n, so that it will become this. We have already discussed. I want to go much more details again. And third step will be then calculate the BI's, calculate the LR of BI square mod n. So once you calculate LR of BI square mod n, okay, like that, just calculate and keep aside, okay, like that. You have to iterate till how many B numbers you want to take, keep like that. And after that, from third step, once you form the B numbers, okay, then the third step is like select the few BIs and represent using the B is equals to capital B equals to PI, I equals to 1 to H, okay. And then see, from the third step onwards, this is the whole algorithm you have to follow. Means whatever we have found, this thing you have to, third step is the same as like whatever we have followed, okay. Now you will get the more clarity, I think so. You may get completely zero if my explanation is very bad, okay. So basically I told at beginning only, this continued fraction is helping us to form the, it is a deterministic algorithm which is helping us to form the set of B numbers, so that we can proceed it. So now since we got the B numbers, right, B numbers only, right. So from that B numbers, you got my point, bro. You calculate so many BIs, bro. Let's say if you take 10 BIs, so you are having B1, B2, B3 and so on, let's say B9 or B10. So from this one, just select some BIs, select some BIs, and from that BIs, so from the top layer of BI square mod n, you find those values. You will get the some bases, no, like -1 whole power something, 2 power something. So from that one, from the factors, I mean basically from the prime factorization of this one, you will get something prime numbers and base power some exponent. So from such all BIs, take union of this all this exponent and form it, name it as a capital B, means factor base, okay. Now you can like you can just convince ourselves like that, okay. So for the B set this, okay, for this B factor base set, these whatever we selected BIs are our BI numbers, and then from that we will follow this whole procedure. You got my point? This is how the things work, okay. So let's say some remarks in our case, okay. We can solve numerical in the next class, I think so. Okay, that's all for the video. Okay, thank you, bye. If you like the video, then comment me. Jai Shri Krishna. Bye.